Some new science this week. So this week we have a study that has been published, or a paper rather, on the study that has been published about evolution in bacteria. And I'm going to pull up a screen share here so you guys can see this. You guys got visuals on the screen yet? Cool. So you can read that abstract there and see what it's all about, or you can just listen to me tell you about it and try to decode some of this stuff that we see here. We can also let Brendan talk about it if he can decode some of it. Basically, Tiffany Taylor of the University of Reading in England basically deleted a gene that controls Flagella growth. And what that did was it removed the tiny tails of this soil bacteria. And so these bacteria rely on this tail so that they can obtain food, and it increases their survival rate. Well, about 96 hours after placing them in a low food environment in which they could not move around much due to the lack of that tail, those bacteria were once again growing flagella. So how did they manage such an amazing feat? Well, two mutations occurred. One in regulatory genes that control the levels of protein in the nitrogen uptake, and the other one turned the protein's job into flagella production control, which basically means, long story short, is that natural selection rewired the genetic networks, these mutations, so this very important feature that these bacteria have was basically evolved back, if that makes any sense. Oh, wow, what layman's term. So basically it came back. They re-evolved. There we go. They re-evolved the ability to create those tails. So, Brendan, I'm going to direct this one to you since you are our resident molecular biologist. You can, I put it in a layman's term, but if I mess something up there, because I only did about 20 minutes of research on it, you can go ahead and correct me there.
Well, it's more than I did, but just from your description there, I mean, sounds very interesting. I'd be interested in looking into obviously all the details of exactly what they did and everything to see exactly if that's the case, what happened. That's very interesting, though. I'm interested in knowing, exactly the gene that they removed, and then if that's exactly the version of the gene that essentially re-evolved or came back, or if it was slightly different, or if there's multiple genes involved in the creation of this tail, or I don't know if it's a flagellum or whatnot. But that's very interesting. I'll be interested in looking into that, because that would be a pretty well-evidenced example of exactly how something like that could come about just that quickly. I mean, that was just within what, a few days, like several hours, whatever. I mean, what was it, 3 or 4 days? So I don't know how many generations that would be for whatever bacterium they were working with, but that's pretty impressive and pretty powerful testament to the power of evolution and natural selection, I suppose.
Yeah. So my understanding is that from reading it is that these bacteria, the gene was removed for the flagella, so they didn't have one. They had no tail. And so their genes actually mutated in order for them to create one without activating that specific gene. So that was my understanding of it. But you're right about that. It's a remarkable feat of natural selection, and it's just more evidence that we can add on to the pile of, actually, let me rephrase that we can add on to the mountains of evidence for evolution. So with that being said, we're going to turn it over to...
Sorry, I just want to. I was wanting to jump in with a correlation, actually. There's actually a specific type of cavefish that has basically evolved out the need for eyes because they live in pure darkness. Well, what they did was they took these fish and they actually transported them to an area with more light, and they actually started to grow their eyes back and start to use them. So this is actually seen in the natural world as well.